Here is the Chapter 5 test review. If you have any questions on this, please make sure that you ask them before Monday because that's when you will be taking your test. So the very first part on the test is going to ask you to solve the systems by graphing. So when we go to graph, we want to make sure that the first thing that we look at in each equation is the y-intercept. The y-intercept is the number that stands by itself. So it's just a plus 3. That means I'm going to go on my y-axis and I'm going to make a mark at plus 3. Then I look for my slope. My slope is the number that's in front of the x. And if you look in this first equation, since there's not a number in front of the x, we assume it to be a 1. Because if I told you that I had an x, I'm talking about 1x. Slope is always written as a fraction, so I'm going to write it as 1 over 1, which means from that first blue dot, I have to go up one space and to the right one space. And I can continue the pattern in the opposite direction, making a straight line. I'm going to connect all of the dots with an arrow on each end. Once I've graphed the first one, I'm then going to go to the second equation. The starting point is our y-intercept, which is -3. So I'm going to go to -3 and I'm going to make a mark. My slope here, I have a negative sign in front of the x, but again, since there's no number, you have to squeeze a 1 in there. Since this slope is -1 over 1, that's directing me down and to the right. So from that red dot, I go down 1 to the right 1, and I go in the opposite direction, and I connect with arrows on each end. The goal of these is to figure out where the two lines intersect, so I just highlighted that point in black. The final answer would be where the 2 points intersect. So the first point that I list has to be on the x-axis, which is the horizontal line, and on our x-axis from the origin we had to go to the left 3, which is -3, and we go up and down 0. So our final answer is -3, 0. Moving on to the next equation, I'm going to start with the top one, starting with my y-intercept, which is 2, so I'm going to make a mark at 2. Then I use my slope to direct me. My slope is 1/3, which means I have to go up 1 to the right 3. So from that point, I go up 1 to the right 3, and I can also continue that pattern in the opposite direction and draw a line with arrows on each end. The next equation has a y-intercept of -3, and remember to take the sign with that number. So I'm going to go on my y-axis and I'm going to make a mark at -3. From there, I use my slope to create more points. My slope is 2, so I'm going to make it a fraction, 2 over 1, which directs me up 2 to the right 1. Up 2 to the right 1, and I continue the pattern until it doesn't fit on the graph anymore. And you'll notice that at a certain point the two lines intersect. That intersection is what we're looking for. If we list the coordinate points of that intersection, on our x-axis we had to go to the right of the origin 3, and we had to also go up 3. So the point of intersection is 3, 3. Number 3 is similar to the first two, in which we have to look at our y-intercept, which is -5. We make our mark. Then we use our slope to find more points. Our slope happens to be 6 over 1. So from this point, we go up 2, 3, 4, 5, 6 to the right 1, and we connect with arrows on each end. So then I go to the second equation. The y-intercept is -4, so I make my mark at -4. And I use my slope to find more points. My slope is 5 over 1, so I go up 5 to the right 1, make my mark, and you'll notice you now see the point of intersection. I'm going to highlight that in black, and I have to give the coordinate point of where they intersect. From the origin, I have to go to the right 1. I also have to go up one space, so the coordinate would be 1 over 1. Problem number 4 is your first opportunity for extra credit on your test. It's going to be very similar to this. And the reason why this one's extra credit is because you'll notice that, yes, we have two equations, but the equations do not have y by themselves. If you look at problem 3, it says y equals something, and the bottom one says y equals something, but on problem 4, they don't. So what needs to happen is we have to take these equations and get y by itself. So on the first equation, we have x plus 3y equals 6. To make it easier, I'm going to identify how many x's we're talking about. So since it just says x, I'm going to put a 1 in front of it. From here, I have to get my y by itself. So when I look at the left side of the equal sign, I notice that there's a plus 1x attached to that 3y. So I'm going to move it to the other side by subtracting 1x. What I do to one side, I had to do to the other, so I'm left with 3y's equaling, and I've got to list my x's first according to my slope-intercept equation. So I have a negative 1x, notice that's right here, negative 1x, and then I have a 6. To identify which sign goes in front of the 6, you have to look at what type of number the 6 is. Since the 6 is positive, I'm going to put a plus sign in there. Now we have one last step before we can get the y by itself. Right now the y is attached to a 3 by multiplication. To undo multiplication, we have to use division, so we're going to divide both sides by 3. So y is going to equal, we've got a negative 1/3 x, because you'll notice we have the negative 1x over 3, plus we have 6 over 3. That division by 3 has to apply to both. I can now reduce this to y equals negative 1/3 x plus 2, because 6 over 3 is equivalent to 2. Now I have it in my y equals mx plus b form. I can start with my y-intercept, which is 2, and then use my slope to identify more points. Since my slope in that equation is negative 1/3, that's going to direct me down 1 to the right 3. So down 1 to the right 3, and I can go in the opposite direction as well to continue on with the pattern. Even if you just do 1, you will get partial extra credit for this problem. The next part would require you to take the second equation, 4x minus 6y equals 6, and again get the y by itself. So what's going to happen is I'm going to look to the side that has my y on it, and now I'm going to move my 4x's to the other side. So I'm going to subtract 4x's from both sides. So I'm left with a negative 6y equals, I'm going to list my x's first, negative 4x, and I also have a 6. Now just like last time, to identify which sign goes between them, you have to look to see what type of 6 this is. This 6 is positive, so I'm going to put a plus sign. The last step would be to divide by negative 6. So that leaves us with y equals negative 4 over negative 6x plus 6 over negative 6. We still have to simplify, so I'm going to write it in simplified form over here. Y is going to equal, now two negatives, we have negative 4 over negative 6. Two negatives are a positive, and 4 over 6 reduces to 2 over 3. We still have our x. Plus, now we have to reduce this one over here. 6 over negative 6, or 6 divided by negative 6, is negative 1. So I now have my second equation. I'm going to start by putting my y-intercept up there, which is negative 1. And then I'm going to use my slope to find more points. My slope is 2/3, which is going to direct me up 2 to the right 3. When I go up 2 to the right 3, I find my point of intersection. The final step for this one would be to list what the coordinate point is, which would be 3, 1, because we had to move to the right 3 and then up 1. On problems 5, 6, and 7, the directions tell us that we need to use substitution. The substitution method comes from when we know one of the variables and we plug in what that variable is to the second equation. So on this first one, it tells us what y equals. It says y equals x plus 3. So in the second equation, instead of using y, I'm going to plug in x plus 3. So that's going to be x plus 3 equals 4x minus 6. Now our goal is to get all of the x's together and all of the numbers together. So I'm going to start by bringing this x over to the other side. In order to move an x to the other side, I'm going to have to subtract x from each side of the equal sign. So I'm left with 3 equaling 4x's minus 1x would give me 3x, and then I have a minus 6. So now our goal is to get that x by itself. To undo the minus 6, I'm going to add 6, which leaves me with 9 equaling 3x. Last step would be to divide by 3, and in this case, x equals 3. Now, many students accidentally stop at this point because they think they have an answer. The problem with stopping at this point is that we have what x equals, but we do not have what y equals. So since we have what x equals, we can take it and we can plug it in to either equation up top. I usually try to take the easier one, and in this case, the easier one would be the top one. So if x is 3, I'm going to just put a 3 right over that x. 3 plus 3 would give us our y, so y would have to equal 3 plus 3 or 6. So now that I have both, I can be done with the problem. Moving on to problem 6, I'm going to do the same thing as before. I look to see which equation tells me what either x equals or what y equals. Since this one tells me what y equals, I highlight that and I have to plug it in to the other equation. So then I'm going to rewrite that equation. Instead of x plus y equals 7, I'm going to write x plus what y equaled, which was 2x plus 4, and then I bring down my equals and my 7. At this point, since the x and the 2x are on the same side of the equal sign, I can combine them together right away. X plus 2x gives me 3x plus 4 equals 7. From here, I work to get the x by itself. So I'm going to subtract 4 from both sides. And 3x is going to equal 3. Divide by 3, and x equals 1. I'm not done yet. I still have to plug in. I can plug into either equation from the top. It doesn't matter which one you pick. So this time, let's say I'll pick the second one. So the equation is y equals 2 times our x plus 4. Since we know what our x is now, we said that that x is 1, I can plug in 1 where I see that x. 2 times 1 is 2, and 2 plus 4 is 6. So when x equals 1, y equals 6. If we move on to problem 7, this one gets a little bit more complicated because we have to apply the distributive property, and I'll show you how that plays in. So I look at both equations, and the equation that has the y by itself is the one on the bottom, 2x plus 9. Wherever I see that y in the second equation, I'm going to plug this in. So instead of x minus 3y equals 12, I'm going to plug in, or equals negative 12, I'm going to plug in what that y equals. So x minus 3, instead of y, I'm going to plug in 2x plus 9 equals negative 12. Because that minus 3 is right in front of the parentheses, that means that that minus 3 needs to get distributed to both numbers on the inside. So I'll bring down my x, but then I have to do negative 3 times 2x, plus I have to do negative 3 times 9, and that's going to equal my negative 12. So I can actually calculate those out. The negative 3 times 2x gives me a negative 6x, and the negative 3 times 9 gives me a negative 27, still equaling that negative 12. Because the x and the minus 6x are on the same side, I can take 1x minus 6x and get a negative 5x. You have to be very careful with your signs, and that's why I would always double check with a calculator on these ones. Because if you make a negative a positive, it throws off your entire problem. From here, we've got to get the x by itself, so I'm going to add 27 to each side. So I get negative 5x equals negative 12 plus 27 gives me 15. divide by negative 5, and x equals negative 3. From here, I'm going to take that x and I'm going to plug it in, and I'm actually going to use this bottom equation. So we're going to do 2 times our x, which was negative 3, plus 9. 2 times negative 3 is negative 6, plus 9 gives us 3. So when x was negative 3, y was positive 3. And again, this method was substitution. For questions 8 and 9, I mentioned in class that you are able to use guess and check if that's the method that you prefer, but I'm also going to show you the math. So the math behind this involves systems of equations like we've been doing for this entire chapter. The only thing is that you have to actually create your 2 equations. The equations need to be based on the fact that for the first one we have 16 animals, some are pigs, some are chickens, and that there are 52 legs. And our answer needs to satisfy all of that. So what happens is I make one equation based on the number of animals, and I make one equation based on the number of legs. So if I'm talking about animals, remember I have pigs and I have chickens. I'm going to call pigs P and chickens C. So if I take my pigs plus my chickens, I get 16 animals. When I come down to the number of legs, I need to remember that pigs have 4 legs, so 4 legs per pig, plus I have 2 legs per chicken. And we need a total of 52 legs. From here, I would probably use the process of elimination to solve this problem. The elimination method is when we need opposites. So what I'm going to do is I'm going to create opposites with my c's. So the opposite of 2c is negative 2c, so I'm going to take the top equation and I'm going to multiply everything by negative 2 to create opposites. Negative 2 times p is negative 2p, plus negative 2 times c is negative 2c, and negative 2 times 16 is negative 32. So now that I have multiplied that negative 2 by everything on top, I now have 2 equations. I have the 4p plus 2c equals 52, and I have the negative 2p plus negative 2c equals negative 32. Using elimination, I can now add these together. 4p minus 2p, or plus negative 2p, is 2p. Opposites give me 0. And 52 minus 32 is 20. To solve for p, I divide both sides by 2, and that gives me p equals 10. Well, I identified at the top that p was representing pigs. That means we have 10 pigs. Now, if we had a total of 16 animals and there were 10 pigs, we would need 6 chickens to balance that out. If I double check, 10 pigs times our 4 legs gives me 40 legs, and 6 chickens times 2 legs gives me 12 legs, and that gives me a total of 52 legs. So I have 16 chickens and I have 52 legs. Number 9, just a reminder, we added in class that we were only going to use nickels and dimes. When we create our equations, we need to remember that there are 19 coins, the total is $1, and we only used nickels and dimes. So I'm going to create my 2 equations, one based on the number of coins, and one based on the total value of the coins. So my first equation, I'm going to call nickels N and dimes D. So if I take my nickels and I add my dimes, I get 19 coins. Now if I take the values, nickels are worth 5 cents, plus dimes are worth 10 cents, and we need a total of $1, which I want to keep consistent and use cents. $1 is 100 cents. I'm going to use the same method as the last problem. I'm going to use elimination. In this case, I'm going to choose to eliminate my dimes, which means I need the opposite of 10 dimes, which would be negative 10. So I'm going to take this negative 10 and distribute it to everything on the top. So negative 10 times n gives me negative 10n, plus negative 10 times d gives me negative 10d, and negative 10 times 19 gives me negative 190. So now I'm done with that top equation, and I'm going to use elimination on the bottom. 5n minus 10n gives me a negative 5n. Opposites give me 0, and 100 minus 190 gives me a negative 90. From here, I have to divide by negative 5 to get the n by itself, and n would equal, if you take negative 90 divided by negative 5, n would equal 18. Since n was standing for nickels, that means I have 18 nickels. For a total of 19 coins, I would need 1 dime. So I now have my answer to that problem. For the next 3 problems, we have to use the process of elimination. With elimination, we need opposites. If you look at problem 10, you'll notice that we do not have opposites at all. The x's are 3x and 2x, which don't create opposites, and the y's are both minus y's. Our rule is that if we have something very close to opposites, you take one equation, I'm going to choose the bottom one, and make everything the opposite. So the positive 2x becomes negative 2x. The negative y becomes a positive y, and the positive 3 becomes a negative 3. That is as if I took and I multiplied the bottom equation by negative 1. So now I go through and solve. 3x minus 2x is 1x, or just x. Opposites give me 0, and 2 minus 3 gives me negative 1. So I have my answer for x. Now I can plug back into either equation. I'm going to choose the first one. So instead of 3x minus y equals 2, I'm going to take 3 times negative 1 minus y equals 2. 3 times negative 1 is negative 3 minus y equals 2. To get the y by itself, I'm going to add 3 to each side, which leaves me with a negative y equaling 5. Many students stop here because they think that they have what y is, but they don't have y by itself yet because there's still a negative sign in front. Remember, if there's no number there, you can always squeeze that 1 in. So I'm going to still have to divide by negative 1 in order to get that y by itself. So y would equal a negative 5. Oop, you can't see my negative sign. So when x equaled negative 1, y equaled negative 5. On problem 11, you could choose to create opposites with either your x's or your y's. I'm going to choose to create opposites with my y's. So what that means is since my bottom equation has a minus 2y, my top equation would need a plus 2y. So if I multiplied the top equation by negative 2, that would give me my plus 2y, because negative 2x times 2x is negative 4x, and negative 2 times a negative y would be a plus 2y, and negative 2 times negative 2 is 4. So now I can go ahead and combine my equations. 1x minus 4x is negative 3x. Opposites give me 0, and negative 16 plus 4 gives me a negative 12. If I divide both sides by negative 3, I get x equals positive 4. From here, you take and you plug back into either equation. This time, how about I'll choose the second equation to plug into. So x minus 2y equals negative 16. Since our x is 4, I'm going to plug that in. I've got to subtract 4 from each side to try to get this y by itself. So I have negative 2y equals negative 20. Divide by negative 2, and y equals a positive 10. Number 12, I'm going to go ahead and create opposites again. This time I'm going to create opposites with my y's. And so since the top one is a minus 2y, the bottom one needs to become a plus 2y. So it would have to be multiplied by negative 2. that creates a negative 20x plus 2y equaling a positive 4. Since that top equation is so far away, I'm going to bring it down. 6x minus 2y equals 10. Negative 20x plus 6x gives me a negative 14x. Opposites give me 0, and 4 plus 10 gives me 14. When I divide by my negative 14, I get x equals negative 1. Now I can take and I can plug this back in. So I'm going to use the top equation. 6x minus 2y equals 10. So instead of my x, I'm going to plug in that negative 1 and go ahead and solve. So negative 6 minus 2y equals 10. If I add 6 to both sides, I get negative 2y equals 16. Divide by negative 2, and y equals negative 8. On problems 13, 14, and 15, there are quick ways to do this, and then there are not so quick ways to do this. So we have a couple rules. I'm going to write them at the bottom. The first rule is if two equations have the same slope, then they are going to be parallel lines, which means they are never going to cross. That means there would be no solution, because we're looking for a solution as to where the lines cross. Our second rule is that if the equations are the same equations, then it's the same line, which means we have an infinite number of solutions. If we have different slopes, that means they are going to cross at one exact point, which means we'd have one solution. So I'm going to show you how we can look for the shortcut method, and I'll show you the way we can figure out our answer if we forget that shortcut. So on the first equation, if I'm using our shortcut, and I look at these equations, I have a slope of 11 and I have a slope of 9. Since they are different slopes, my answer would be one solution. I'm just going to put that at the very bottom. One solution. And that's for problem 13. Now that's the shortcut method. If you don't remember the shortcut method, then this is how you would figure out your answer. So I'm going to take my equations and I'm going to use substitution. So since I know what y equals, I'm going to take what y equals and I'm going to plug it in for the y in the other equation. That gives me 11x plus 8 equaling 9x minus 7. So our goal would be to now solve for x. I'm going to bring these 9x's over to the other side, which leaves me with 2x plus 8 equaling a negative 7. Now I've got to bring my 8 over. Oop, I said negative 7 and then I wrote negative 9. Hang on one second. So now I've got 2x equals negative 15. When I divide by 2 on each side, I get x equals negative 7.5. And if you notice, I have exactly one answer, or one solution. At that point, you can solve. When I go to problem 14, a lot of students began to notice that the second equation was just 2 times the first equation. So my 14y doubled was 28y, my x doubled was 2x, and my 6 doubled was 12. So a lot of students said right off the bat that these two are the same equations and it would be an infinite number of solutions. If you wanted to prove that, what we could do is we could do system of elimination. So elimination requires us to have opposites. So if I took and I wanted the opposite of 28y, I'd have to multiply the top by negative 2. When I do that, that gives me a negative 28y equals a negative 2x plus a negative 12. That gives me 0 equals 0 plus 0, because everything here is opposites. Everything became the same. When both sides are the same, your answer becomes an infinite number of solution. means that they're going to be the exact same line, and every single point on both lines are going to be an intersection. When I go to number 15, the shortcut is to look at the slopes. The slopes are both 15, and if we look down at the bottom, if they have the same slope and they're not identical equations, it's going to be no solution because they'll be parallel lines. If I took this and I used substitution to plug in, I'd have 15x plus 1 equals 15x plus 2. Get my x's together by subtracting 15 x's from each side, and that leaves me with 1 equaling 2. But if you stop and ask yourself, does 1 equal 2, you know that it does not, which means no solution. Problems 16 through 20 are going to be very similar to the first 4 problems on the test. All we have to do is we have to graph the left side and we have to graph the right side. So I'm going to start with my y-intercept, which is -1, and then use my slope, which is -2 over 1. That directs me down 2 to the right 1, down 2 to the right 1. Then I use my second equation. My y-intercept is -3, and my slope is -1 over 1. So from that point, I go down 1 over 1, down 1 over 1, and I have found where they cross. Just a reminder that you have to have your coordinate point listed for your final answer. So on our x-axis, we had to go over 2, and on our y-axis, we had to go down 5. So that would be a -5. There's your answer. Number 17, my y-intercept is +1, and my slope is 3 over 1. So from there, I go up to 3 over 1. And I can also go in the opposite direction to see where they intersect. For the second one, my y-intercept is 2, and my slope is 4 over 1. What you'll start to notice on this one is that if you go up 2, 3, 4 over 1, you're off the graph. So what happens is you have to go in the opposite direction. You could go down 2, 3, 4 to the left 1, down 2, 3, 4 to the left 1, and that's where I notice I find my point of intersection. The reason I can do that is because 4 over +1 is the same as -4 over -1, because 2 positives are a positive and 2 negatives are a positive. So it's going to still go in that same direction. My point of intersection would be -1, and then I had to go down to -2. Number 18 provides some challenges for students because what they don't realize is that the first equation is listed in a different order. So a lot of students go to say that the y-intercept is -2. And that's not the case because our y-intercept is the number that stands by itself. So in this case, the number that's by itself is 1. So that's the y-intercept. That's where I'm going to start. My slope is always found next to my x. So in this case, my slope is -2 over 1. So from here, I have to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. I can connect with arrows on each end. So then I go to graph my second one. My y-intercept is +1, and my slope is down 2 over 1. When I'm graphing this, I realize that these two are the exact same line. And when we have the exact same line, our answer, I'm just putting it up top, is the infinite number of solutions because every point on both lines is a point of intersection. Number 19 is going to be extra credit, another opportunity for extra credit. And the reason being is it's easy to graph, however, the point of intersection is the difficult piece. So with this one, I'm going to start with my y-intercept at -2, and then I use my slope, which is -1 over 2, directing me down 1 over 2, and I'm going to go in both directions. So then I take my second equation, it's a +1. My slope is 3 over 2, which takes me 1, 2, 3 over 2. It takes me off the graph. So I'm going to go in the opposite direction. Down 2, 3 to the left 2, down 2, 3 to the left 2, down 2, 3 to the left 2. Notice they all go in a line, but what you also should notice is that they don't cross at a very nice point. They're kind of in the middle of a box. So in order to figure out where they cross, you have to take this equation and actually solve it. So negative 1/2 x minus 2 equals 3/2 x plus 1. I'm going to go ahead and get all of my x's together. So I'm going to move this minus 1/2 x over to the other side by adding 1/2 x. So that leaves me with a negative 2 equals 3/2 plus 1/2 is 4/2, or just a 2x. So I could erase that 4 over 2 and write it as a 2, because 4 over 2 is 2. So now I can go ahead and solve, and I get negative 3 equals 2x. If I divide both sides by 2, I get x equals negative 1.5. You'll notice that if I go back 1.5, that kind of lines up with my point of intersection. So now I have to choose. I can use either of the top equations and plug in for x. So I can choose either the left side or the right side. I'm going to choose the right side. So if I take 3/2 and I multiply by what my x was, negative 1.5, and then add 1, I'm going to get my y value. 3/2 is the same as 1.5, so I'm just going to convert so that they're both in the same form. 1/2, or 1.5 times negative 1.5 is negative 2.25, and if we add 1 to that, we should get our y value. Y would end up being negative 1.25. There's your solution. Again, this is extra credit. If you're looking for opportunities to raise your grade, then I would suggest doing problems 4 and 19 and asking questions before you go to take your test. If you happen to have any other questions, please feel free to email me before the test on Monday. It is sullivana@milton.k12.wi.us.